All right, let's take a look at how to graph rational expressions. So to look at these rational expressions or rational functions, here's really what we're going to take a look at to graph this. Now, this really isn't steps like we normally do. This is really what we're going to go after to help us graph this. Step one, we're going to find our x-intercepts. And we're going to find y-intercepts, always easier to do. Find vertical asymptotes. Step 4, find horizontal asymptotes. And next to this one, remember there's one special case for horizontal asymptotes when we actually have a slant asymptote. So we'll actually be looking for that as well. Now the last step we may or may not have to do. We may have to plot some more points. So for each one of these problems we're going to take a look at, we're going to find x-intercepts, y-intercepts, same way we always do, let x equal to 0, let y equal to 0. Find our vertical asymptotes, horizontal asymptotes, and if we have to, we're going to plot a few more points. Okay, so let's just start out with an example. Let's just say it said graph. Let's say we got y is equal to 2x over x minus 1. And we were told to graph this. So for our x-intercepts, remember for x-intercepts you always let y be equal to 0. So we get 0 is 2x over x minus 1. Clear your fractions. So we get 0 is equal to 2x. We get x is 0. So this would give us a point on our graph, 0, 0. For our y-intercept, again, like always, we let x be equal to 0. So we get y is equal to 2 zeros over 0 minus 1. 0 over negative 1, which is 0, so that's another point. We get 0, 0. For a vertical asymptote, remember, it's anywhere the denominator is equal to 0, but not the numerator. So what that means is you take the denominator, set it equal to 0, and solve. Now you want to do a real quick check here. Take this and plug it into the top. If it doesn't make the top 0, then it is a vertical asymptote. So since that makes the top equal to 2, we have a vertical asymptote at x equals 1. The last thing we want to check for is a horizontal asymptote. Now remember, this is just a set of rules that we had to remember. Now in this case, notice the degree of the top is 1, the degree of the bottom is 1. So the equation for our horizontal asymptote is the ratio of those coefficients. So we get the line y equals 2. Okay, so just for room's sake now, let's go back over here and put together the stuff that we know. We know we have an x-intercept as 0, 0. Y-intercept is 0, 0. Vertical asymptote is x is equal to 1. Horizontal asymptote is y is equal to 2. All right, so let's see how we can put this information together, and maybe some more points. We may have to come up with some more points here to see if we can sketch this graph. Okay, so here we go. Okay, first thing you want to do is always sketch your asymptotes, because that's kind of the framework for this problem. We have a vertical asymptote at x equals 1. Now remember, that's a line that this graph can never, ever, ever cross. We have a horizontal asymptote at y equals 2. Now technically you can cross a horizontal asymptote, but it's kind of weird. Generally, if you are going to cross a horizontal asymptote, it's right here close to the origin, not farther away. Okay, so you see how this kind of broke the board up into 4 regions. The vertical asymptote is the big delineator. It separates in the left and right, which means I have graph over here, graph over here. Now generally, the horizontal asymptote is also going to separate the graph. So on this side, generally the graph's going to occur up here or down here. Same thing on this side. Generally the graph's going to exist up here or down here. So let's see what information we have. We only actually technically have one more piece of information. We know the point 0, 0 excuse me, point 0, 0 is on this graph. Okay, so here's the idea. Let's work on this side over here. I know for a fact that the graph approaches the horizontal asymptote as we head towards infinity. So as I go this way, I know that this has to approach that asymptote. not supposed to touch, I kind of touched there. All right, now we know as we go towards a vertical asymptote, the graph's either going to turn and go up or turn and go down. You can kind of see the trend of this graph is that it's already kind of heading down, so the graph's most likely going to do that. All right, so we have the graph on the left side. What about on the right side? Well, notice we don't have any information over there at all, but we actually have enough information to go ahead and draw the picture. Because if the graph was going to be down here, it would have to approach it that way and go this way, but notice I would cross the x-axis if I was over here. I don't have any more x-intercepts, which means the graph cannot exist here, which means the graph's got to exist up here, which means it's got to head towards that way and turn up when it goes this way, which means the graph looks like that. All right, so you notice even when you don't have points, you can reason out where the graph is. Now, if you couldn't figure out from, saying, okay, the graph has to be up here because we don't have any more x-intercepts, what you could have done is just pick another x value over here. So like the x value of 2. So if we plug in that, what was our original graph? Was 2x over x minus 1, I hope. If we plug in 2, that's 2 times 2 over 2 minus 1, 4 over 1, which is 4. So if you came over here, plotted the point 1, 2, that's actually pretty close to where we are. Then you would know the graph was up there because that's where the point would be. So if you're not sure what's happening in a region, pick a point in that region to see if it'll help figure it out. All right, let's try a couple more of these because these can be a little tricky. Again, same directions, we're still graphing. Let's say that this is our function now. Let's do 3x over x squared minus 4. 3x over x squared minus 4. All right, so do me a favor, pause the video, see if you can find the x-intercepts, y-intercepts, vertical asymptotes, horizontal asymptotes, and slant asymptote if it has it. All right, let's see how you did. Let's go after x-intercepts first. We know for x-intercepts, we let y be equal to 0. Let's go ahead and clear these fractions. So we get 0 is equal to 3x dividing by 3. All right, so we do have an x-intercept. It's the point 0, 0. For our y-intercept, we let x be equal to 0. So that's 3 times 0, 0 squared minus 4. 0 over negative 4, which is 0. So we have a y-intercept, 0, 0. Vertical asymptote occurs anywhere the denominator is equal to 0, but the numerator is not. That's easy to solve. Take the square root. So we get x is plus or minus 2. So we have 2 possible vertical asymptotes. Now remember, for each one of those values, you want to plug it back into the original and see if it makes the numerator equal to 0. Notice 2 makes the top 6, negative 2 makes it negative 6, so both of those are vertical asymptotes. For our horizontal asymptote, we have to check our rule. Here, the degree of the top is less than the degree of the bottom. So our rule tells us our horizontal asymptote is the equation y equals 0. So hopefully this is all the information that you got from when you did this. So I'm just going to pull all the information over here to the side so we have room to graph this. Our x-intercept was 0, 0. Our y-intercept was also 0, 0. We had 2 vertical asymptotes at 2 and negative 2. And our horizontal asymptote was y equals 0. All right, let's see if we can put all this together. And we might have to plot some more points here. Okay, you always want to put your asymptotes on first. We have vertical asymptotes at plus and minus 2, and a horizontal asymptote, which is the x-axis. Now, generally you want to do it just a little bit above or below so you can actually see that horizontal asymptote. Now, the vertical asymptotes now break the graph into 3 regions. So we have 3 regions that we need graphed, kind of over here on the left, on the right, and in the middle. We only know one point. There's only one more piece of information we have, and that's the point 0, 0. All right, let's just start from one area. Let's go over here to the left. Now, since I don't have any x-intercepts over here, I kind of get the idea the graph's going to either be like this or down here. Since I don't have any more information, the only thing we can do is just pick a point. So let's pick -3. So if I plug -3 into my function here, I get 3 times -3. -3 squared minus 4. That's -9 over 9 minus 4, -9 fifths. Okay, now all I really cared was negative. That's -1 something. So I'm going to get that out of there. So that just means it's down here somewhere, which means the graph over here exists in this region. Now let's skip over this one because we're going to talk about that in a second. Let's go over here. It's really the same idea of what we did on this side. Since I have no idea what's going on over there, let's just, again, pick another number. We plug that in here. That's 3 times 3, 3 squared minus 4. That's 9 minus 4. So that's +9 fifths. So this time, this graph is over here somewhere, up here somewhere. So this piece looks like that. All right, so that takes care of the ends. Now what's happening here in the middle? Well, there's actually only 4 choices. Think about it like this. As we leave this point, and when I go left, I can either go down or I can go up. As I leave this point, I can either go up or I can go down. So there's 4 possibilities of what can happen. So again, kind of like what we've been doing, you're just going to have to pick some points and figure out what's happened. So what happens as we go to the left? What happens is I plug -1 into there. That's 3 times -1. -1 squared minus 4. That's -3 over 1 minus 4. -3 over -3. So that's up there 1. So that's right there. So you can see as I go towards -1, the graph is heading up, so it goes like that. All right, what happens as we approach +1 then? So that's 3 times 1, +1 squared minus 4, 3 over 1 minus 4, 3 over -3, which would be -1. I'm going to get that out there. So that means that this time it's going down, so our graph is heading that way. Okay, so this is a good example that where the information that we got from kind of doing our 4 pieces wasn't enough, and we had to go and find some arbitrary points. So don't be afraid to go over to the side and just plug in some values to help you figure out what the graph is doing. All right, one more example. Let's take a look at y is equal to, let's do x squared plus 1 all over x minus 1. Again, do me a favor, hit pause. See if you can find the x-intercepts, y-intercepts, vertical asymptotes, horizontal asymptotes, and slant asymptotes, if it hasn't. Go. All right, if you're back, let's see if we can find all the pieces here. For my x-intercepts, again, remember we let y be equal to 0. Clear our fractions. So we get 0 is equal to x squared plus 1. So -1 is equal to x squared. So plus or minus square root of -1 is x. So that's plus or minus I. Well, since that's imaginary, that means we're not going to have any x-intercepts. The graph never touches the x-axis. All right, for our y-intercept, if we let x be equal to 0, we get 0 squared plus 1 all over 0 minus 1, which is just 1 over -1. Okay, so we do have a y-intercept, 0, -1. Let's see, vertical asymptotes occur anywhere the denominator is equal to 0, but the numerator is not. So we take the denominator, set it equal to 0, and solve. We get x equals 1, and notice if we plug 1 into the top, we get 2, so that's okay. That is a vertical asymptote. Now, if you do get 0 on the top as well, that just means that there's a hole in the graph there. So you don't draw a vertical asymptote, you would just do a hole. I know you've seen those in the graph before. So that is a vertical asymptote for us. For our horizontal asymptote, we have to use our rules. Since the degree of the top is bigger than the degree of the bottom, there is no horizontal asymptote. However, the degree of the top is bigger than the bottom by 1. So here, this is actually no horizontal asymptote, but we do have a slant asymptote. Remember, to find the equation of a slant asymptote, you have to do long division. So let's see, x squared plus no x's plus 1. X times x squared would be, x times x is x squared, and distribute, that's minus x, subtract x, bring down the next piece. To multiply x by 1 would give us an x, so that's distribute and subtract, that gives me a 2. So that's my remainder. So remember, the equation for the slant asymptote is y equals the answer without the remainder. So that's just y is equal to x plus 1. I just displayed before, let's go over here and get all of our information together. X-intercepts, we don't have any. Y-intercept is 0, -1. Vertical asymptote is x equals 1. No horizontal asymptote. And we do have a slant asymptote, and that's y equals x plus 1. All right, let's put all the pieces together and see what this graph looks like. Okay, so remember, we always want to put our asymptotes on there first. So we have a vertical asymptote at x equals 1, and a slant asymptote of y is equal to x plus 1. Now remember, this is in slope-intercept form. So this thing has a y-intercept of 1 and a slope of 1, so up 1 over 1. And then draw yourself another dotted line through there. Okay, the vertical asymptote breaks the graph into a left side and a right side, and then the slant one kind of breaks it into, again, kind of bottom and the top. So like over here on the left, the graph is generally either going to be up here or down here. And in this region over here, the graph is either going to be here or up here. Now we do have one more point on here. We know the graph goes through 0, -1. So that's that point right there. So looking at the left-hand side, I know I don't have any x-intercepts, so I can't go up at all. So as I go to the left, just like when we approach a horizontal asymptote, we're going to approach this slant asymptote that way. And as I go towards that asymptote, I can't go up because I don't have any x-intercepts, so I got to go down. Now this region over here, you can see it can't be in this region here because I would cross the x-axis, which means the graph has to be up here in this region. So it's going to kind of look something like that. All right, so that's what this graph would look like. And again, if you couldn't figure out what it looked like in either region, you can just pick points from each side, plug it in so you can figure out what the shape looks like.